So today we're talking about radical expressions, and some of this you may already be familiar with, and some may be a little new. The first thing we want to do is to simplify, and of course we know pretty well how to simplify radicals like radical of 81. We can take the square root of that very easily. But what happens if I have something like just radical 80? Well, I don't know a square root of 80 very well, so what I'm going to do is do a prime factorization. And I'm going to break it down into all its prime factors. So it might do 2 times 40. 40 is 2 times 20. Or I could do 5 and 8. It really doesn't matter how you break it down because you're going to get the same prime factors in the end. So I get a whole lot of 2's and a 5. I'm going to circle my pairs. So I have this pair of 2's and I have this pair of 2's. And then my 5 is my lonely number. I take 1 from each pair. So I take 1, 2, and 1, 2, and those 2's come outside the radical, so I have 2 times 2, and then my lonely numbers stay in the radical, so this time it's just 5, and then I can kind of finish multiplying things out. 2 times 2 is 4. There's nothing inside the radical to multiply, so I just leave it as radical 5. So I have 4 radical 5. And we've had some practice with that, hopefully in the past. Because we want to move on to something where I can have like a radical 2 and I'm multiplying it by a radical 14 and how that works. Well, because they're both in the radical, I can multiply them and keep it inside a radical. So 2 times 14 is 28 and I keep that inside the radical. But then, maybe I still want to break that down and get my simplest form. So I'm going to do the prime factor tree and I say it's 4 times 7. 4 is 2 and 2. I have my pair of 2's and my lonely 7. So I would pull one of my 2's out in front of from one of the 2's from the pair and leave my lonely number 7 inside the radical. And that would be my answer. Okay? Try this one by yourself. Radical 6 times radical 8. We should get radical 48. Which if I do a factor tree of, and I'm not going to break it down all the way to its primes because I can see that pair of 4's hanging out, and I would do 4 radical 3. So it works really well on those kinds of numbers, but it also can work if I have something like 90 x cubed y to the 4th z to the 5th. And like, how the heck do I break that down? Well, I'm going to prime factor every piece of it. So I can break it down into the square root of 90 times the square root of x cubed times the square root of y to the 4th times the square root of z to the 5th. So I can kind of use that reverse thing. Instead of multiplying them all together and having them under one giant radical, I can kind of break it up and solve each piece. If I break up 90 and do the prime factor tree, eventually I'm going to get 3 radical 10. There's 3 x's in here, so I take out 1 from the pair and leave 1 inside. Y to the 4th, if I take the square root of that, just becomes y squared. And z to the 5th, I have 5, so I take 2 of them out and leave the lonely 1 inside. And if you need to see like how that looks in terms of a factor tree, there's z squared, z to the 3rd, z to the 3rd is z squared, z. I have my pair of z squareds and my lonely z inside. And once I have this kind of broken down and simplified, then I can start combining things back up again. And I can say all the things outside the radical. Well, that's a 3x, a y squared, and a z squared. And then I can say all the things inside the radical. Well, that's a 10, an x, and a z. And that made it a lot simpler than going from this straight down to this. Okay, so we're going to do another one of these just to kind of get the practice. So we'll start with 32 r squared k to the 4th t to the 5th. So again, I'm going to break it up into the 32 times the radical r squared times the radical k to the 4th times radical t to the 5th. 32, if I were to do the prime factor tree on that, you do 2 and 16, and then this is 4 and 4. So maybe I'd say that's my pair of 4's, and radical 2. R squared, the square root of that is just r. K to the 4th, the square root of that is just k squared. And if you remember back from my z to the 5th on last one, we had, with t's now, it's just t squared radical t. And I combine everything outside the radical, so 4r k squared t squared, and everything inside the radical, 2t. Okay? Perhaps you've heard in the past that we don't love to leave denominators in radical form. And that's completely true. We like to do what's called rationalize the denominator. So if I have a fraction inside the radical, the first thing I absolutely want to do is to simplify it. So I know that 35 and 15 are both divisible by 5. So if I divide top and bottom by 5, I would get the radical of 7 over 3. And that's lovely, and if you were, any younger, you could leave it like that. But we're not. We're big algebra kids, and so what we can do is we can kind of break that up into radical 7 over radical 3. And I'm okay with having radicals in the numerator. It's in the denominator that we don't like it, because we don't like negative exponents. And if it's in the denominator, it's, like to the negative 1/2 kind of thing. So I'm going to multiply top and bottom by what I have in the denominator, which is that radical 3. And then that's where, when we did multiplying radicals together, this really comes in handy, because I now have radical 21 over radical 9. Well, we know radical 9 is 3. And I can leave a radical in the numerator and just come up with that. Okay? And that looks a lot prettier if I have to start adding things together or using this in any way. It's a lot easier to find a common denominator when your common denominator is a whole number instead of a radical. So that's this process where I multiply by the denominator, or the radical in the denominator, is called rationalizing the denominator. So we're going to try another one of these. So let's say we have radical 45 over 10. And go ahead and simplify that and see if we can come up with the rationalized denominator on your own. Good, we're going to simplify it to radical 9 over 2, which I can break into radical 9 over radical 2. Multiply the top and the bottom by radical 2. So I would get radical 18 over radical 4. Radical 4 we know to be 2. Radical 18, if you're doing a factor tree, is 9 and 2, 9 is 3 and 3. So I would get 3 radical 2 over 2 as my final answer. Okay? Where rationalizing the denominator comes in really handy is when we want to do conjugates. So let's say I have 3 over 5 plus radical 2. Well, I can't just multiply by radical 2 because it's being added to the 5. So what I'm going to do instead is to multiply by the conjugate, which is kind of the opposite. So I'd take 5 minus radical 2 and multiply it on top and bottom. And how this is going to work is on top you're just going to go ahead and distribute the 3 to all these different things. But on the bottom, I have 5 plus radical 2 times 5 minus radical 2. This works a lot like FOIL. And I'm foiling perfect squares, essentially, where I have 1 plus 1 minus. So I really only need to do the first terms, so 25, minus my last terms. Radical 2 times radical 2 would be radical 4, which is 2. So that would be my denominator. Up top, 3 times 5 is 15 minus 3 radical 2. And I can leave this as 15 minus 3 radical 2 over 23. And we're used to seeing things like this because this is a kind of solution we could get if we did a quadratic formula. Okay. So conjugates are really important, and so we're going to try one on our own. We'll have 1 over 4 plus radical 12. And so multiply by the conjugate and see if we can simplify it down. So hopefully we multiplied by 4 minus radical 12 on top and bottom. On the top, that's really easy because I distributed with a -1, so I would just have 4 minus radical 12. On the bottom, you FOILed. But again, those middle terms are canceling since one is a plus and one's a minus. So I would have 16 minus 12, which is 4. So I have 4 minus radical 12 over 4. If you didn't see this when you were working the problem, radical 12 can be simplified because it's 4 times 3, which is 2 and 2. So I could have 4 minus 2 radical 3 over 4. Well, then if we remember back to when we did quadratic formula, I see something on top where I can factor a 2 out. So I have 2 times 2 minus radical 3 over 4. This 2 cancels, that becomes a 2, and my final answer would be 2 minus radical 3 over 2. If you didn't get this bottom step, but you got to this point, that's a really good amount of progress. And we can tackle the rest of it with the simplifying in class, but make sure we're at least getting to this part with the conjugates. The last big subject we want to talk about is adding and subtracting with radicals. And this kind of works like with variables. We can only do things with like terms or like radicals. So this works out really well because all of my things have a radical 2. So I can say 5 plus 7 is 12, minus 6 is 6, and I keep what's in the radical as radical 2. That works out really nicely. For instance, try this, radical 7 minus 6 radical 7. Remember, there's an understood 1 here. Good, we should have gotten -5 radical 7. Those work really nicely when they have like terms. But what would happen if I had something like radical 8 plus radical 12 plus radical 18? Well, first of all, if I'm looking at these, let's try to break these down. So 8 is 4 and 2, which is 2 and 2. I'll circle my pairs, underline my lonelies. So this one I have 2 radical 2 plus 2 radical 3 plus 3 radical 2. So I have some radical 2's, and those I can combine. So 2 plus 3 is 5 radical 2. And then this one doesn't have a like term or something else with a radical 3, so I can just keep that on the side. And that would be my final answer, okay? Subtraction works the same way. You just subtract what you need versus adding. So let's go ahead and try one on our own. We'll do radical 27 plus 2 radical 3 minus radical 12 and see if we can solve that. So hopefully we got that to simplify to 3 radical 3 plus 2 radical 3 minus 2 radical 3. Of course, a plus 2 radical 3 and a minus 2 radical 3 would cancel, and my final answer would be 3 radical 3. So this one I was able to combine all the like terms. Okay? Let's look at another example here. And this is going to look a little different. We'll have 3 radical 2 times 2 radical 6. And what happens here? Well, I can multiply my outside numbers to start. 2 times 3 is 6. And I can multiply what's inside the radical. So radical 12. If I break down radical 12, we've seen multiple times that that becomes 2 radical 3, right? But you can't forget about my 6 hanging out at the outside. Okay, so I need to multiply that 6 and the 2 to get 12 radical 3. And we'll try one of these on our own as well. So if I have radical 5 times radical 2 plus 4 radical 2. See if you can handle this one on your own. It combines a couple different things. Good, if we work inside the parentheses first, that becomes 5 radical 2. And I would multiply by radical 5 on the outside. When I multiply, I have my numbers out front. That's a 1, understood 1. So 1 times 5 is 5. Inside the radical, I get radical 10. And that would be my answer.